Hi, everyone.
Hello.
Hello.
Okay, so I think we're enough people already, so I'll start. Hi, everyone. For everyone who doesn't know me, my name is Bogislava Bogaliska. I work at VMware at the Cloud Management Business Unit, and I'm currently a member of Technical Staff Level 2. I've been in the company for 2 years. And recently I've been working on a project which uses this plugin-oriented programming paradigm. And I got really interested in it and decided to research it. And here I am talking about it. First of all, I'm guessing each one of you in some way has encountered plugin in their development life. So I think there are some reactions in Zoom. Can anyone do some reaction if they've ever worked with some sort of plugins? Okay. Not a lot, but I'm sure you're kind of shy. So yes, you probably have an idea of what plugin-oriented programming will be, and I think it won't be the same thing you're thinking. So let's go into it. So what we'll cover today, there's quite a long agenda. We'll see first why we need this programming, what are the problems that we're solving. Then we'll go over the key ideas of the paradigm, what are the concepts that drive it. Then we'll see the particular implementation and what components it has so we can actually program in POP. So POP is plugin-oriented programming. Then we'll take a step back and see, look at the big picture, see how we're solving the problems, how it compares to other paradigms, and so on. And then we'll go over IDEM, which is the project I'm currently working on, and it has quite a bit of hype around it. So I'll show you what it does. And just quickly, I might mention how it's implemented in POP, but probably we won't have much time for that. And finally, some takeaways. So let's start with the motivations. So just quickly, I'll go over a little bit of history. And here we see what problems we were trying to solve at the early days of programming. So we had mainly math problems. And so we expressed that with language which is quite close to the math, and it's procedural. And then appeared the need to write software maybe for system administrators. So Unix was born. And with it, a lot of other ideas came into life. So the Unix philosophy of having small programs that handle text and have simple interfaces. And then we went over more near days where there are personal computers and web development. And so software evolved, became bigger, and we needed some more abstractions and other concepts. And here object-oriented programming came into life and was really useful with, and I'm sure you all know enough about object-oriented programming. And so where are we now and what problems are we solving? Well, actually, today we're solving a little bit different problems than we were 20 years ago. And most of them have to do with the scale. So scale of the software, how big is the software, how many features it has, scale of the amount of customers, the requests, the parallel requests, scale of the teams. The teams are distributed across multiple locations. And we have the whole open source community where we have developers all over the world collaborating on a single project. And another pattern that we're seeing is that monoliths, which were the way software was written in the past, are now kind of legacy, and we've went over to the microservices approach, where we have smaller projects with a single responsibility, so we can manage all this complexity. And given that picture, how we program now, I think it's pretty much the same way we did before. So maybe programming didn't evolve as much as the problems we're trying to solve. And that's why these problems are still that big and hard. So we still have, object-oriented, that's of course, we still have Linux. We have these big projects which do all sorts of stuff. And as the project evolves, I believe everyone has seen how it's quite hard to fix a bug, for example, because you have to trace over a massive repository, or you do something and another unrelated thing breaks, or you're trying to add a feature and just the architecture doesn't allow it. So that's the symptoms which we're trying to address with POP. And here's a quote of Linus Torvalds, probably everyone knows him. And he says that he's not a programmer anymore, that he doesn't have any time to write code, that he just writes the code reviews and emails. And that's the job of a lot of the good developers at some point, because they now have the expertise and everyone depends on them to do code reviews and stuff. And we don't get really the productivity which we'd want from them. And here is a list of a lot of the problems. Some of them I already mentioned, and I'm pretty sure you've all stumbled upon at least half of them. And I won't stop right now, but we'll go over them again. And the question is, how could we do better than this? And POP proposes some answers. And here are the key ideas which underpin it. So first of all, I'm going to break the myth about what plugin-oriented programming you think might be. So probably you think of it as the picture on the left, because that's how normally we have plugins. We have a large software, a large platform, and we want to have some extensibility to it. So we leave a place for plugins, so people can write a plugin for a specific external software. And that's what plugins are. But that's not what plugin-oriented programming wants. POP wants everything to be a plugin, which is a very important concept, because that means that at every point of development, every functionality, every method on a very small level is very extensible, and you can think of replacing it or extending every piece of the software with a new thing. So that makes the whole architecture very flexible for new changes or for replacements of old logic. The second main idea is that we have all these plugins, and we don't want them to be like the thing on the left, which is a bad practice, a class or a file which does multiple things at once, and methods which are 2,000 lines of code. What we want is these plugins to be extremely small. So we want them to contain a very simple functionality. And actually, I myself went over and added the third column of purple stuff here, because even the yellow ones aren't small enough for POP. So we want very small plugins, and we also want very small projects. And this might seem familiar to you, because I took the picture from a comparison of monoliths and microservices, actually. And the idea is pretty much the same. We don't want a single project, a single repository, which has multiple functionalities, which don't have almost any correlation. We want to extract every piece of functionality we can into a different project, into a different repo. And then we have the ability to mix and match them in different ways, like shown on the right, and have much more flexibility, plus the additional benefit that small projects are easier to write and maintain. And another key difference of POP and other architectures are in the way projects are structured. So traditionally, these things on the left, everything is a project with different colors. So on the left, we have 4 projects, and normally we structure our project hierarchically. So think of these nodes as directories and files. And on the left are how projects are now. We have 4 projects. While on the right are how projects are structured in POP. So we still have the same structure internally, but externally, projects themselves are in a big hierarchy with one single root. And this gives us a big benefit of the next key idea, which is project merging. So on the left, we have the same 4 projects. And if we want to use them, if we want to use one in the other, we do some importing logic, we do some glue code, and it gets kind of ugly. While on the right, the whole thing is the POP way of solving it. So you still have the 4 initial projects as shown above. I don't know if you can see the mouse. You still have the same 4 projects, but they have the same roots. And then you have this concept of project merging, which means that even though the projects are in different repositories, once you install them at runtime, you will have all projects running as one under one common root. And this gives us the ability for one project to invoke another without any glue code, because all this merging is handled internally by the POP framework. And those were the key ideas. So again, I'll go over them because they're the most important. So first, everything is a plugin. So we have a very extensible pluggable software. Plugins and projects are small. Both projects internally and externally are organized into this big hierarchy, which allows for merging based on the hierarchy. And this minimizes the glue code for integrating and reusing code, and maximizes code reuse because it's simple. And all this is kind of abstract. This is the paradigm, but it's implemented in a way in that we have a Python implementation of a framework. It's called POP, and it allows you to write your apps in a plugin-oriented way. So POP is installed easily, and we also have the POP create tool, which generates the boilerplate of the code for you, so you can straight away start writing code. And this is used for item. POP create, you might think of Maven archetypes. If you're a Java person, it just creates the whole project structure for you. So let's see what components POP has. And here I'm kind of using interchangeably the paradigm with the Python implementation, because currently there's only one implementation. And it might look different if it gets implemented in other languages, just saying. So first of all, the plugins. We already mentioned them. There is something small, but what exactly are they in POP? So a plugin in the Python implementation is just a single file, a single Python file, which, let's say, contains just functions. And those functions are exposed publicly, which means that if you have the plugin installed, everything on the app can access all its methods. And plugins, because they're super small Python files, I said here onboarding takes a few hours, but maybe even a few minutes. So it's really easy to onboard. And they have a single responsibility of doing some very small functionality. And now plugins, as we mentioned, the hierarchical structure, are grouped into the green things, which are called plugin subsystems. And they're just a way to abstract a way you can think of a small functionality. So if there's some functionality which you need to implement, you might use a lot of plugins grouped under the same sub. And they're in the file system, they're usually like directories. So you can think of the plugins as files and the subs as directories. And the root, which is again common for all projects, not just for one, is called the hub. And here we see how a plugin generally looks like. It has functions. They accept the hub as a first parameter. So you have a reference to that thing here inside every method of the code. They're usually asynchronous and exposed by default, which makes us write better code because you know this function can be used from anywhere. And you can also make a function private, but that's generally not the right way to go. You can just underscore it at the beginning. And yeah, there's no privacy. Now, having all this extensibility and letting everyone extend the code however they want, we need to have some rules for all of this. So if someone writes a plugin, we have to have a way of verifying it's correct, that it follows our conventions, our logic. So we can be sure that the system will work correctly when it's loaded. And to do that, we have contracts. So contracts have kind of two functionalities. One of them is the first one, which enforces an interface. So what function should a plugin contain, what parameters it might take, and so on. And the other is to be able to inject code before, after, or in place of some function code. And this is done just so we can extract all the logic, which is common to a set of plugins inside the contract. And so the person who actually has to implement the plugin has to implement the minimal amount of functionality which they need. And the code is as simple as possible with no duplication. And yeah, so you can use, for example, the preconditions for validating input, transforming input, or doing the same on output, and so on. And we also, plugins are dynamic, so they're loaded at runtime. And also which plugin is loaded can be different based on some conditions, which is this virtual loading. So we can have the same on the name of the plugin, the actual one which stands behind it. The actual function which gets invoked might be different. So this is a sort of polymorphism. And we just said that plugins contain methods. So you might be thinking, well, what about all the data? And POP takes an interesting approach to this because the data isn't contained like an object oriented inside an object which is coupled with its methods. Instead, the data is also attached on the same tree along with the subs and the plugins. And it's actually accessible from anywhere in terms of you can read it from anywhere. And that solves a lot of the over encapsulation issues which occur in big projects because we often, when we have a large project and from one part of the code, we want to get the data from another part of the code, that might be quite challenging because there's just no pathway to it. And we have to troubleshoot, we have to write some ugly code and just lower the quality. And here we don't have that because data is very easily accessible by its name. And the next thing is that actually that gives us sort of a structured heap because all the data that is created has a name and location which we can access. So we kind of have control over all the data, unlike the heap. And I mentioned access. So everyone can read a certain data. So this is data. And every plugin on the whole tree, on the whole project, can access the data, but it still has the ownership element of object-oriented. So only the plugins which are in this subtree should modify it and should own it and manage it. And this gives us the ability to do a little bit different stuff with the data. For example, we can have our own version of garbage collection because we know where all the data is, so we can handle it, we can release it when needed. And also, because everyone can access it, it's very easy to communicate between plugins using some data on the hub, and that can be used to synchronize some processes. And we mentioned a couple of times that we're referencing stuff on this tree. How do we do that? Well, everything has a name, the data, the subs, the plugins. And if we want to access any of them, we just go from the root to the thing. So if we want to say this plugin, if we want to use it from anywhere, we just say hub.s1, s2, p1. And now we have access to the plugins methods. And now we go into app merging. App merging is, for me, one of the most beneficial concepts that Pulp gives us, which is that once we have this this common hierarchical structure of projects, we can have multiple projects and merge them into one. So how does that work? Here we have one project. So think of this as one repository, and this is another. And they define two different subs. So kind of two different functionalities, unrelated. But let's say we want to use one in the other. So transparently, just by installing them in the same Python environment, we can pop under the hood, can merge them and make this big project, big app, in which referencing anything from one project to the other is just made by its name. And this is called horizontal app merging because we're merging different applications into one so that we can reuse them. And this is kind of like importing libraries. And the other app merging is vertical. And that means that one project, for example, let's say an open source project, defines some code, some functionality. And you have an individual contributor who wants to extend this functionality with some of his own for his personal needs. So this can happen instead of forking that project and working on it and then trying to keep it up to date with the upstream. The second developer can just create just the amount of functionality which he needs in his project. So he can extend this S1 sub with his own set of subs and plugins to extend the functionality of the upstream project. And then he can merge them into this one project, which he can run without any need of communication with this other repo. So extending a functionality is really easy because we have this vertical merging. So here is just that S1 is the same in both places. So the trees are merged under the same root. And yes, this is using for extending others' code without having to write to the same project. And having all this app merging, I'm sure many of you are asking yourselves, how is that even possible to merge two arbitrary projects into one? And it's not that straightforward to do, but luckily Pop takes care of all of that. So one of the things that is a bit of a struggle is that every app can have its own configuration, be it environment variables or configuration files or command line options, and it needs them to function. And when they're both merged, Pop takes care, the Pop framework takes care of also merging the configurations. So each app can access its own configuration, even when it runs along other apps. And it does this by using a common way to define command line options in each POP project. And then it unifies them under the hub. So it creates a dictionary on the hub, which is called opt. And for each app, defines a dictionary of its configurations. So that way, when some app is running, regardless of what other apps are also running, it can access its configuration in a predictable place. And you have the added benefit that in no POP project, you need to parse command line flags or configuration files or environment variables, because POP does that transparently. And the other thing you may stumble upon is that every app has its own initialization logic. So what happens when we have two apps and how that initialization logic is handled? Well, every sub and every plugin has a way to define what to do when it's loaded. So for example, here is some small plugin, and it has this special init method in which you can say any initialization logic. So here we initialize some data on the hub, as you can see. And you can also load other subs which you may need to reference here. And also you have the startup script, which every app defines, again, in a consistent way. And then you have to say in the merge tab which script needs to be executed. So the whole point of POP is that projects are written in a consistent way, so that then under the hood POP can automate some of the stuff and make developing easy by abstracting away that glue. And we've went over most of the new stuff. So we've went over the ideas, we've went over the main elements of POP. And now I'm sure you're asking yourself a lot of questions like, why do we need this? Does it help? So this section is for that. And here is the slide again with the problems we were facing in the beginning. And I want to just quickly say how POP solves these problems. So first was the code base scalability, that code bases become big and you can't really manage them effectively. And POP solves that by saying have small projects, and then we can easily merge them into one so you can have all the functionality which you want. The developer scalability is the problem where if you have a lot of developers working on the same project, they kind of hinder each other and you don't get the speed of development which you want. As people grow, it actually might slow down. And this is, again, partially because of the big code bases and the complexity of the code and how fast it is to develop the change, then how fast it is to merge the change and how fast the pipelines are. And all these are a function of the size of the code base. So this is also a problem that's solved. The developer productivity follows. Then we have complexity, and POP really emphasizes that everything should be very simple. You have very simple files, functions, everything is structured in a simple way. So you can easily spot where to do your change, and you can find your way around the code easily. The system rigidity is a big problem in legacy systems, because if you've ever worked on one, you know that solving a bug is really hard to trace everything, to troubleshoot, to debug, and then to actually make the change without breaking anything else. And that's solved in POP by having everything extensible, every stage, every layer of the application being a plugin. That makes you, that gives you a lot of freedom in making changes in isolation from others. So instead of changing something, you add something which doesn't break stuff. The maintainability, again, is a function of the complexity and the size of the code base. The open source collaboration is an interesting point. So what I mentioned about Linus Torvalds, who didn't get to program because he's reviewing all the time. Well, now he gets to have his own repo where he can program, and other people can have their own repos where they can extend that. And pretty much all these can be merged and everyone can get the functionality which they need. And of course, at some point, you may choose to merge some of the extensions into the original repo, but you're not blocked by it. You get a lot of code reuse, again, because everything is made so it can be used by everything else. Everything is kind of a library, and you can easily reuse other projects. And yeah, you have the over-encapsulation problem largely solved because you don't have the data encapsulated in so many layers of objects that you can get to it, but you actually can get it quite freely, which might pose some other problems, but not the over-encapsulation. And the general code quality is improved because of all of that, because you're made to write your code in an extensible way, and because you know everyone will use your code, you write it better, you document it better, and so on. So we say that POP is a paradigm, and many of you are probably thinking, well, what happens to the rest of the paradigms? Do we throw them out the window? And the answer is no. Here is a comparison to object-oriented. So they're largely different layers, as we'll talk about in a moment, but still, conceptually, I see one big difference between them, and that is the encapsulation bit. So in object-oriented, we have the thing on the left where we have one rope, which is the methods, and one rope, which is the data, and they're just tangled in one unit, and you don't get one without the other. And on the right, we've detangled those. So now we have methods and we have data, and they're both accessible. And methods do operate on data. They still have a link, but they're not so tightly coupled. And so that's the encapsulation bit. Also in POP, there's no inheritance between plugins. So you do stuff by composition. And you have the polymorphism, which we mentioned, and also you have the abstraction. Is this whole structure of this tree is generally an abstraction. And here we can see in this picture that this is the data and these are the methods, and the data is not in the plugins. That's the difference. And when we talk about object-oriented and what's good about it, often we mention the solid principles. And it turns out that POP actually also might follow them. So the single responsibility one is that every part of the application should have a single responsibility. And that's very much the case in POP, because you have plugins which have a single responsibility and projects which have a single responsibility. The open-close principle, again, is very POP, because that means that everything is open for extension, but closed for modification. And that's exactly what plugins are. They're things that makes you open for extension. And the risk of substitution might be a little bit tricky because it has to do with inheritance, and we don't have that. But I look at it from the standpoint that every plugin which follows a certain contract is interchangeable within every other which follows it. We have the interface segregation, which means that interfaces are small. You only have to implement the interfaces which you need. You don't get to drag stuff which you don't need. And that's, again, exactly what plugins are. You only load the plugins which you need. They don't have any excess stuff in them because they're maximally divided. And the dependency inversion is that you must depend on abstractions instead of concretions, which again is you depend on these names on the namespace and not actually on the plugin. So the concretions are the plugins, and which plugin is loaded at runtime is not concrete. So essentially, POP turns out to be solid. And another programming paradigm which is used in POP or has influenced POP is flow-based programming. So I'll just touch on it that its main idea is to have these processes, which are black boxes of something which processes input, output. And then you have this network which interconnects all the processes and actually makes a flow from the input to the final output. And actually, they should be asynchronous. And this is quite, this is quite like plugins. So you can think of these processes as plugins, which you can rearrange however you want to get your flow. And plugins are also generally asynchronous in nature. But the difference is that we don't have multiple processes, we have one process. And here is the question of, does POP replace other paradigms? Should we not ever write object-oriented code? The answer is no. I wouldn't advise such thing. The thing is that POP kind of is one layer above all else. So you have the other paradigms which are closer to the languages, to the maths, to the machines, and they have this lower layer abstractions. And POP gives you one layer of abstraction more, so it's closer to how humans think, how humans process, how it's more intuitive to program. So essentially, in your POP code, in your plugins, in your methods, you can absolutely use object-oriented programming or functional or everything else. It's just Python code. And the thing is that POP gives us this additional structure and enforces these good patterns and has this additional automation so that you get all the benefits that we mentioned. And here's a quote from the author, actually, that you shouldn't need to understand an underlying abstract base class to be able to extend the system. So in POP, you don't have to do that. You just have to write another plugin without having to understand why all other plugins work. And the final question, which you probably have been asking even before the presentation, is why is that even a paradigm? And that's another tricky question because it's kind of also in Python sense, it's just a framework for writing code. But the sense of POP as a paradigm is more like the key ideas which we covered in the beginning of how we want to structure our code and to write it, how we merge different projects and then deploy them as one, and how do we collaborate between teams, how do we divide projects into different repositories, how do we maintain code. So that part of the philosophy of how to program is why I believe it can be called a paradigm. And here I just have one slide to clear probably another confusion which you may be having about how is this any different from microservices, because microservices, again, try to have functionality divided between different repositories and have single responsibility and so on. So that part is the same. But I'd say the concept of merging is the most important one to consider, because microservices, they're developed in isolation, and they also get deployed in isolation, and then they communicate over a network, for example. While in plugin-oriented programming, you have these different repos, but at runtime, they merge into one application. So it's not multiple processes, multiple containers, it is one. So we have the benefits of having microservices at development time to have more simple repositories, better and faster developing, more distributed developing, but also at runtime, we have the simplicity of having a single process which is running. And now we reached the point where I will talk about items. So first, maybe I can ask if you have any questions until now. So if anything has interested in you, also you can ask anytime in the chat anything about plugin oriented, because now we'll go into a project which actually uses it. Okay, so there's a Q&A in the end also. Okay, so we'll go into item, which is a concrete project which I'm currently working on. And its job is to manage multi-cloud infrastructure. So we have multiple clouds. We have AWS, GCP, Azure, and we want to have a single tool with which we can manage any infrastructure on any of these clouds. And the concept of item is to be infrastructure as data. So what does it mean? It means that all of that infrastructure which you have on the cloud, all the instances, all the networks, disks, all their properties, they are reduced to just data in a simple YAML format, which is called SOS. And that way you have a YAML representation of your whole multi-cloud infrastructure, which item can take for you. It can scan your environments, and it can also enforce it on the cloud in the reverse direction. So here we see that you have some cloud data, which is some cloud infrastructure. And with item, you can describe it into item states, which are these files. And then you can edit anything in those files and enforce it using the item state command. And it goes to cloud data, so it updates the cloud data. And the main thing about item is that its name comes from idempotent, which means that no matter how many times you apply a certain configuration, the output isn't changed. So you don't have the problem of, have I applied this file, or if I apply it a second time, it will break everything and leave the system in an inconsistent state. So it solves this problem of managing quite easy the infrastructure. And on the next slide, we see this again with a concrete example of provisioning some AWS resources. So again, we have this loop of, we have infrastructure, describe it, get the SOS, and then do whatever changes you may want to do, and then enforce them to change the infrastructure. And this SOS here, in this example, is this YAML file here, which defines a VPC network and a subnetwork with some properties. And then once you enforce it with item, you get the actual resources in AWS. And so I've prepared a quick demo to show you how that works. So if anyone knows me at all, I'm quite the coffee person. So most of my examples are with cappuccinos. And here, so item is this separate repository, which you can find. It's quite, it's actually not quite big, but the whole point is that you can extend it, not by forking that project and making any changes, but by simply making your own project and writing whatever plugins you may need for your specific resources. So here I created a new project. And by the way, creating a project is very easy. You just have to use the pop create command with the item cloud subcommand. And then you say what project, what's your project, what's your name of the cloud. So I've already done that. And here I have the structure. And I decided to create my own cloud. So my cloud is called Bobby Cloud. And in the cloud, I provision cappuccinos. So this is the only thing I do. And for that, I only had to write this simple Python file, which defines 3 methods for managing the said resource. So I want to manage cappuccinos on my cloud. And what I may need is to create, to update, to delete, or to see what cappuccinos I have. So for that, we have 3 methods in item, which we need to implement. One is the present, which is used for create and update. One is the absent, which is used for deleting a resource. And one is the describe, which is used for listing a resource. So this is all the code I needed. It can even be written shorter. And if I go now and say item describe, this is the item command, but if I give it now my path, which is this one, Bobby Cloud Cappuccino, it automatically knows where to go and to list the cappuccinos which are currently offered. And now I can simply take what the describe command has returned and paste it in an SLS file. So here. And now once I have this SLS file, I can enforce it. So I'm saying this is what infrastructure I want on my cloud, enforce it. And here we see that one is named 1 and has a big size and the other is a small size. So once I enforced it, we see that both resources already exist and are up to date. So let's say that I want to make this big medium. So I simply, if I want to change some resource, I change its description in the SLS. And now I enforce it again with the item state command. And now what we see is that Cappuccino 2 is up to date, but Cappuccino 1 exists, but we updated its size to medium. And now if we describe, we can see that we have the 2 resources and Cappuccino 1 now has medium size. And this shows that we've updated it on the cloud. And the final thing is how to delete resources. So deleting resources is done by, again, specifying an SLS file where you say what you want to delete using this path here, which is the path to the plugin function, as you may see. So we can now enforce this. So this SLS file is called to drink cappuccino. And now once we enforce it, we see that cappuccino has been drunk. And now the describe command returns that we have just 1. So that's the main flow of how item works. You just have these YAML resources, YAML files in a specific format, which describe your whole cloud as data. And then you can enforce that state onto the cloud as you've defined in your plugin for the concrete resource. So do you have any questions around item? Okay, so I'll go back to the presentation to finish it off. So as I said, item is implemented in POP, and it's interesting to see. Okay, there's a question actually. A question about the paradigms implementation. How does POP compare to other plugin frameworks like plugin? Okay, so I don't know this framework, but essentially other frameworks I don't think will be done in accordance to this POP paradigm because it poses some brand new concepts of these mergings and the whole hierarchies, how you use data and so on, and the whole automation under the hood. So you can definitely use other frameworks for writing plugins, but if you want to write your code from the ground up with this paradigm, I'm pretty sure other frameworks just aren't designed to do that with that in mind. And does POP has strict definition for plugin? I wouldn't say a very strict definition. In terms of the framework POP, a plugin is a Python file with some methods. And in terms of the paradigm, it's any entity which is small enough and has some small functionality. Do we need to configure the item default functions every time before we start using item as an infrastructure management tool? I don't think so. When you want to start using item, the only thing which you have to configure if you want to use management over a certain cloud is the accounts. So we have to specify the account you're using for the cloud so item can authenticate to it and be able to list and manage resources. But other than that, I don't think there are any other functions which you need. You can just straight ahead start with item describe for the resource. And then you get this SOS file which describes your whole environment. And then you can edit any property and enforce the new state. So it should be quite straightforward onboarding. Okay, thanks for the questions. And now how item is implemented in POP. So the whole thing we want in item is this extensibility. So we want everyone to be able to extend item however they want by writing their own plugins in their separate repositories. And this is where POP really comes into action because that's exactly what it's made for. So POP item defines these subs. So the subs are those directory, I believe, green circles we had. And we have the state sub, for example, which is the interesting one. As you can see in my project, I actually wrote a plugin under the state sub. And this is all you have to do to extend item because item has the state sub and it knows how to manage it. It knows to go into all loaded project, go through their structures, load all their plugins. So then when you have an SLS like this one, when you specify your resource, your path to your resource, item will see the resources you've defined it in your own project, and it will find the functions inside there, and it will call them. So that's kind of the beauty of how we do extensibility. And how this is done is you have this contract, which is the resource contract, which defines these three functions, which need to be this way. So they need to be called present, they need to take the hub and context, also absent and also describe. And so item knows to look for them and to invoke them dynamically as you provide an SLS. And POP create item is a project which makes generating item plugins automatic. So instead of you writing your whole item provider by hand, for example, we have a lot of resources in GCP, and our goal is to be able to auto-generate all of the resources based on some generation logic instead of having to hard code each and every state file. And POP create item really comes in handy for that, for generating state files, exec files, and so on. Okay. And so finally, the takeaways, which we have, are that you don't have to really do POP. You don't really have to implement your project with POP. You can do any sort of, you can take any concept of it, and then you can apply it to your own project. So any of the key ideas which you found, they're not new, they're old, and they've stood the test of time. And you can absolutely apply them with just object-oriented, for example, and they can still suit your situation. And also, maybe if you don't even do that, maybe just think about your project which you're currently developing, and think about how would you restructure it, how would you implement it from the ground up, so that it's in plugin oriented way. So what would your projects be? What would your subs be? What would your plugins be? And so on. Or simply get inspired by the fact that someone decided to reinvent how we structure our programs, how we write code, to rethink this whole process. What are its benefits? What are its drawbacks? And decided to think of something new. It might not be the best one, but you can invent it in a better world. So that's for the takeaways. And I've listed some resources, both on POP and on IDEM. And with that, I thank you, and I'll leave open a Q&A. Also, I've left my email for anyone who wants to contact me or say any feedback. If they've tried POP, I'd be interested to learn how it went. Good read for the paradigm. There's one pretty much source for it, or maybe two. This is the POP book here, which says all about the paradigm. And here is the documentation for the POP framework in Python. So how to actually use it and apply it in your Python projects. Thank you.
Thank you for the great talk, Bobby.
All right. Bye, everyone.
Bye-bye.